we could slowly start with the introduction, see if people will join still.
Yeah, no problem.
So we have a very basic concept webinar today. It sounds very simple, de-energize versus energize, but you will see that it is not so simple as some people think.
Let's introduce ourselves. So here there is Tino van de Capelle. Tino Capelle is the ones that don't know him. He's very professional in his activity, 30 plus years experience in the process industry. And he's a functional safety expert and trainer for 2-4 Island for maybe 15 years, Tino, probably?
Yeah, 15.
15. And he's GMI expert for functional safety trainer and topics. And today we explain a bit more about the energized versus energized situations. Myself, Andras Paror, I'm a global account manager. I work in GMI International since 2015. I'm responsible for main accounts and also I'm responsible for, also for European accounts. I'm also functional safety engineer, but not expert as Tino is. So let us introduce a little bit the company. So GMI International is a company founded in 1993 from the former Icon Instruments company. And we are specialized in intrinsically safe and self-certified devices for main, topic and really hazardous area application, safety-related applications. So oil and gas, chemical, petrochemical, pharmaceutical. We have our facility in Milan, but we have also global presence in all 5 continents. And as we say, we are our production in Milan, Italy. We have a complete automated production with pick and place machines. Of course, we have also complete facility for incoming and outgoing products. And also we are proud to say that we have full testing for all our products. That is very important. So every single unit that the customer is buying has been tested. Okay, see here an overview about our production. So we produce intrinsically safe barriers, so isolators, that is better to say, safety relays, isolators for non-IS applications, safety power supplies, multiplexer for hazardous applications, termination boards for DCS manufacturer, hard multiplexer, surge protections, indicators, and also the last bullet is a manual for functional safety application that we printed out in more than 25,000 copies during the years. That is the 4th edition. That is free also for our customers. So later, if you would like to have one copy of that, you just send us an email and we provide a copy to you. And this is our presence worldwide. So we have 10 offices in different continents, but also we are working with a lot of distributors in the main countries. 200 people is our total staff. And we provide also 18 functional safety engineer courses per year. And Tino is our trainer for that. It is also number installation in all continents. So we have a lot of proven application. This is more or less our customers, some main customers, so divided by system vendors like ABB, Schneider, Honeywell, and so on. EPC customers, so most more important names like Saipem, Borley, or Equinont, or Bechtel, and so on. OEM customer, people that use our products in their applications, and end users, so that end users that qualify GMI for their application. Now I leave Tino to the topic of today. If you want to make just one or two information, if you want to make any question to us, there is now the chat is not available, so you have to use the Q&A button, and we try to answer live to the question. Okay, thank you, and I leave Tino to the topic.
Okay. Can you release the remote control,
Yeah.
Andrea? Thank you. So thank you for all the people sharing. As Andrea was introducing, we are both sitting in a different country. He is now in Italy. Currently this week I'm in Germany. Doesn't matter. We are providing today this webinar, which is a very basic topic. It's called the de-energized to trip versus energized to activate. On the list of participants, I can see that there are certain names that are repeating, so it's like a fan box for the moment. People are following the same webinars over and over again. Nothing wrong with that. So when you have any question or doubt or comment, please use the question and answer box. And as Andrea is saying, we will try to answer them all. We also pre-selected quite some good questions. I mean, there are always some good questions, but we selected some very interesting questions. And we have made at the end of this session, we have made a question and answer slides where I prepared some answers for most of those questions related to the topic. Right, let's start off. Here the basic safety principles. As a majority of you probably will know, for every safety instrumented function, which is called a SIF, you shall specify very specific in a document called Safety Requirement Specification, you shall specify exactly what this safety function has to do. One of the items is that you need to put the requirements relating to, do I need to energize my output to activate the safety function, which is very rare to see, or do you de-energize the output of your system, enable to take the energy away, enable to go to a safe position of your safety function. So the safety requirement specification in the current edition, which is edition 2, which is the second last bullet on the slide. In the second edition, which is part 1, which is a normative section of the standard, they have a specific section where they are describing 29 specific items per safety loop. So one safety instrument function shall describe and shall include, and that's one of those 29 items, as I just told you, is energized or de-energized functionality of your safety loop. I made an abbreviation, and you can say, well, there are many abbreviations available on the market, and I fully agree. But for the sake of simplicity on my webinar today, I call de-energized to trip, I call this a DET, or de-energized to trip. And very clearly, it's important to understand we want to trip the safety function, we want to stop the safety function to go to a safe position. That is the basic principle to understand. So that's also the reason when we are talking about de-energize, take the energy away of your safety function to go to a safe position. That's what we call a fail-safe principle. In other words, you take away the instrument there, you take away the electricity, if there's now a pneumatic signal or hydraulic signal, you take away the energy, you remove the power, and your safety function shall go to a safe state. That is one of the fundamental items in safety industry. Common examples here of subsystems that will make a transition of your system to go into a safe state are typically known the shutdown systems, sometimes called the ESD systems or the trip systems. Those are all the classical examples of a de-energize to go to a safe state. I made here a very simple example from end to end. It means from left all the way to right. You see here we are building the safety loop with different subsystems. We have here a transmitter. We go here through a barrier of GMI. We go in here into a safety PLC system. We go into a safety relay as called the interposing relay. We mainly will go into a solenoid, and the solenoid will take away Of course, it is here not the correct picture, but just the principle. The solenoid will take away the instrument there here of your actuator here of a final element. So assume that we have a one-to-one loop. That means we have single sensor all the way to a single final element. That is the principle of the example we're going to use. And you can already imagine how many subsystems, different subsystems, different configurations potentially you could have in here. But the final element here at the end is to de-energize. You take away the instrument there to go to a safe state. And of course, if you would have a safety instrumented function description, we need to know what do we have to measure, what do we have to do in terms of logic here in the middle, and what is the final element. And basically, if you talk about safety instrumented systems, or if you talk about a de-energized to trip application, we always go over a digital output from our control platform into a final element environment. So we open or close a valve, we start or stop a motor. Those are about 95% of all the potential safety instrumented functions out there in the market. Right, I got the first poll question coming up. That is for Andrea to launch this, this poll. Okay. And the role of the power supply, and I'm talking about the power supply itself to feed your instruments. So think about the field power supply for your instruments and for your devices in a de-energized to trip. And I got a few questions here. The first question is, and that is the poll question that you are allowed to try to answer. The first answer is A, the power supply plays a reliability issue for that safety instrumented function. That is answer number A. Number B, the power supply for your instruments or your devices or your subsystems is a availability issue for that safety instrumented function. That is your answer number B. And there's only one answer, the most complete and the most correct. So it's almost like one of the exam questions of our training courses. Item number C, the role of the power supply for your instruments or your subsystems can be both a reliable issue or it can also be an availability issue. Answer number D, it is irrelevant for a de-energized to trip application. And answer number E, none of the above. So we will leave the poll open for a while. There is no points to score here. It's just I want to have a feeling, what is your ID, what is your interpretation of this specific question. So think about the role of the power supply and think about the topic de-energized to go to a safe position. Is that reliability, availability, or both? Or it is irrelevant, or it is none of the above? That is the potential answer. And I propose to Andrea that we still leave a few more seconds because not everyone has clicked the box. And that's what we want to see. We want to see some participation. So you follow a webinar free of charge. So show us that you, and I see someone is filling into the Q&A. Don't fill it in there. Fill it into the poll questions because there we can share the poll answers with everyone. That is the purpose of our poll question. I think, Andrea, we are about to be closed because, let's say, the majority have voted. Okay, then you have to change the poll, Andrea. We have to go to the answers. All right. Well, we see here the majority of the people is saying it's a reliability issue for a safety instrument function. And I kind of like this answer, but I will keep this for the moment. Let's first go to the other ones. It is an availability issue for that SIF. That's only 13%. And I have only 25% are saying it can be both a reliability issue and also a availability issue. And personally, I will say why I like this answer the most, and I will explain it in a minute. Let's first finish the rest. We only have 13% saying it is irrelevant for the Energized to trip application. And although it's only 13% of our poll of the people who came on the webinar today, I can say that irrelevant for the de-energized to trip application, that's a very common misunderstanding of the functionality of the power supply. And if I would be very, very brief and short with you, I would say yes, you can say de-energize to go to safe position. The role of the power supply is not relevant. I would say many people make that mistake in thinking, and I will say why this is a mistake. That is why the answer can be both a reliability and also an availability issue. That is the only most correct and also the most complete answer. That's also the reason why we do this webinar today, because we're going to try to explain this a bit more in depth. Now, why is this an availability issue? Well, there are items requirements specific for the vendors of devices and or power supplies that needs to think about under voltage, over voltage, rush in current. All those items have to be monitored from the 61508 point of view. I can give you a very practical example of why this became a big issue for a large end user somewhere in Europe. There was an offshore platform that had a overcurrent where the fuse was not blown, resulting in actually damaging the final elements. In other words, when that platform had to go to a safe shutdown, the final elements actually could not act anymore because for whatever reason, the overcurrent was not protected the way it was damaging also final elements. Equally, under voltage to some final elements in a certain configuration can also be an issue. So in terms of safety, it is a reliability issue because if you have a power supply that cannot feed the function it was being designed for, it can actually stop your safety functions from achieving it. And this is also an availability issue. Although we speak about the Energized, it can be both reliability and availability. Okay, I will stop sharing and I will try to explain a bit more in detail now. Let's first talk about normal process condition. Normal means nothing is wrong, everything is perfect, all your subsystems are working fault-free, there is no internal failure, even your power supply to your devices is all exactly as it should be. It is accurate, it is available, no overcurrent, no overvoltage, no undervoltage, etc., etc. What I just explained to the second bullet here, reliability, it's all about the accuracy of your power supply. It's all about the undervoltage and the overvoltage diagnostic protection against latch up or high rush in current or against overcurrent. All those items are specifically described for the hardware development section, part 2 of the 61508 edition 2, which is a 2010 release. That's what we say over here. That's also measured in the effectiveness of the techniques and measures used to try to avoid and to try to control those type of failures. Availability, if you really talk about the availability, you can say, well, availability has been around the corner for 30 or 40 years. And I would say, me coming as a background as an instrumentation engineer, where we build like diode bridges on our power supplies to build up a certain, let's say, functionality as availability, I would say yes, that is also available for many years. However, load sharing with hot swappable backups, etc., are kind of items that you may have to look into the availability. And if you want to know more about specific and details about power supplies, what makes a power supply now SIL rated and what not, I would recommend to go to one of the webinars, as we have them all pre-recorded or all recorded on the YouTube channel from GMI. There are certain webinars specific handling those type of topics. Of course, also your instrument air needs to be available. And your instrument air is another weak point that sometimes in design can stop your instruments from doing the right things. It needs to be free from any dirt, from any contaminants, such as, for instance, moisture or some specific items that are left behind in your pipelines. As some people will know that during commissioning and startup, you may find some weird things in your pipelines which do not belong in there, even in your instrument air, pipelines, etc., etc. Execute the safety function. Let's come to the bottom here of the Energized to trip. We have to measure something and we have to shut down. Let's make this as a simple example. That means measure something. That will be measured here in the interlock. It's somewhere in the safety PLC. Once your trip point has been reached, or once your trip point has been going through, that is where the final element needs to do the right function it has been designed for. Typically, a digital output channel will de-energize the output and will try to open the contact of your interposing relay over here. And then that interposing relay on his own will try to remove the power here of the final element. First of all, the solenoid, and the solenoid will try to vent the air of the actuator of the final element. That's all normal practice. I don't think I have to explain more about this. Let's go a little bit more in depth, and let's start here with the interlock. The interlock itself will be some application program written in a modern safety PLC. Again, we will not go more in depth about this, but now we come to the final element, and now we come, to the final, let's say, conclusion. We need to remove the power to the final elements over here. I give you here an example of two different types of a interposing relay from GMI, which are specific model numbers, and that's typically known as NO, stands for normally open contact. So the safety function of the interposing relay is to remove the power. So in case you are removing the power here on the, let's say, the inlet or the inside, the input of the interposing relay, then the output has to be built in a multiple fashion way as they show over here to remove the power. And again, if you want to know more details, we have another webinar, which are real applications for relays with line and load monitoring, which is a specific webinar, I think, which also Andrea has been giving very recently, which can also be found on the GMI YouTube channel. What is now so special about a simple interposing relay? Well, the interposing relays are not as simple as you may have thought of, because they are full of intelligence inside that little box, inside the little relay. And the intelligence is known as a kind of a diagnostic. That means the signal that needs to be sent out to the field is also be monitored and fed back into the diagnostics intelligence. And if for some reason what the relay is trying to send out is not what is being measured back as feedback signals, that will be alerted into a diagnostic message, which they show over here in this example, which is the picture I show you here, which we call this a smart interposing relay. They can feed this signal back to your control platform. So provide that this smart relay is somewhere in between your control, let's say safety PLC, or your control, let's say your BPCS system, towards the final elements. Well, you can feed this signal back into your control platform to say something is wrong in the field. It may be a short circuit, it may be maybe it can be a over voltage, can be under voltage, whatever could be the reason. That can be fed back into the diagnostics to your control platform. And I give you here two examples, left and right. On the left-hand side, here we're going to put the load on. That means the load, if this is a normally open contact, all those contacts needs to be closed, enabled to drive the load, enabled to keep the solenoid energized. Enabled to de-energize, the simple answer is we have to open the load, we have to remove the power, and that is the purpose of using such a relay as we show here on the left-hand side. Now, as you can see here on the right-hand side, in case even the relay here would be open, we also do here a short circuit, or we also do here an earth leaking monitoring, and that monitoring is what is fed back into our diagnostics. That is a relay based on diagnostics example, which we show here, very simple with this schematic. Again, more details are available on the webinars of GMI. Now, if you move from the relay into the solenoid itself, and I took here an example of the industry, and you may think, well, that's a very complex, let's say, replacement of one single solenoid. Well, you can already imagine the majority of all the failures in the industry are always here on the final elements. Without pointing a finger to the vendors of those type of material, it is purely based on practical experience and feedback from the industry that 50% of all the safety instrumented functions are always here, those two final elements. Either the solenoid, mainly the final element itself being your fail to close or your fail to open valve. And why is that? Because those instruments, those substances, they tend to be in a position for many months in one position, which is typically always the opposite position of safety. Because you try to keep your plant running, you try to keep your production ongoing. That means those solenoids, those final elements are typically in an open position, enabled to produce. Enabled to go to safe position, you have to move those items. And if they haven't been moving for a long time, that means stuck on mechanical problems on such type of systems are typically known in our industry. As you can see over here, and I took here the courtesy of a friend of mine in the industry. He is presenting here it's called a sill stroke tree picture, which is a 2 out of 4. As you can recognize maybe here on this picture, you see here on the left-hand side 2 solenoids and on the right-hand side 2 solenoids, and both are being fed back in this PLC over here. They do continuously block and bleed. They are measured, and that's a 2 air pad enabled to replace this one single solenoid. That's sold, or that's actually been used here as a practical example into a box. Call it here your solenoid box, where you have some test buttons, where the tests are done either automatically through this block and bleed, and the stroke of the valve is being measured back with some pressure measurements. Again, that's replacing one single solenoid, because if one single solenoid is stuck open, you will not be able to go to a safe position. Unfortunately, I don't have a clear example of a solution, let's say the solution for this final elements. The only thing I can say, which actually is pleasing myself and maybe many people that are listening into this webinar, is that although it's not available today, there is already a let's say committee working on a specific standard, which is called functional safety standard, specific for safety related automated industrial valves. I give here a reference, which is a technical committee 69, which is the work group number 1. That's here the reference of the work group. That's going to be a SINELEC standard. That's what they are working on. Because frankly speaking, what are we struggling with in our industry? How do we judge how reliable this is? Because it may be an assembly of subsystems, the body of the valve, the actuator of that valve, and maybe the positioner, maybe smart positioner of the valve, yes or no, are all maybe coming from different vendors. How do we make the subsystem, being your final element, how can we predict reliability if all different vendors are giving maybe no or maybe limited information? And that's where in our industry we need specific help. And that's what I'm saying here. That's what is coming up. The forecast is not really clear until now. It's not out yet. That's what I can certainly confirm today. But the question is, will it be out next year or in 2022? That's something which unfortunately I cannot answer you. Right, let's look at the time. Let's move on. And we have a next poll question before we start the Energized to activate mitigation layer. And the question for the attendees that are still online is here, as per 6.15.11, which hardware concept can be SIL suitable or SIL compatible? And I have a specific question for you. Do you think it's only for de-energized to trip for the prevention layers applicable? Or do you think we can also use the SIL concept suitable or compatibility to the Energized to activate for both A and B, or for none of the above? And I made this poll question again because of the common misunderstanding in the industry. And again, we're going to wait until we have the majority votes. So we're not going to continue until at least you do a click. That also proves you are still awake and you not just attend the webinar without doing anything for us. And I think, Andrea, we're going to go most likely to the same majority as before. So we do have a few sleeping people online or afraid to click. Which, come on, people, it's show a bit of respect. I'm not doing this here free of charge for GMI. They still have to pay me. So show at least that GMI is doing some good investment to make some awareness in the industry. Again, You're not losing your face because we do not know who is clicking the button. So answer that poll question. I think, Andrea, it's time to close because some people are very reluctant to answer. All right, well, we do have 78%, which is a big chunk of, let's say, the majority here, are saying it can be both applicable for A and B, which is, you are right, it's the most correct and the most complete answer. Those who are thinking it's only applicable for de-energized to trip, well, that's only 22%. That's, let's say, that's the most common misunderstanding of the edition 1 of the standard. That's why edition 2 has made some new statements, which I also made a copy here in the slides. So it's coming from technical report number 4, but I will show that in a minute. And of course, both A and B is the most correct and the most complete answer. All right, let me just continue. Right, let's go just the opposite in our, let's say, philosophy. Now we're going to energize those final elements, those outputs to do something. And I do know in the very old standards, in the very old seminars, webinars, training we have done, we even myself, we used to call this energized to trip. And basically, energized to trip, I always had some trouble to pronounce this because I said, how can you call something energized to trip? When you not trip, you just start the functionality. I'll give you an example. Typically fire and gas, typically sprinkler, deluge systems. You start the pump, you have to have the water available, you have to open the sprinkler to do something. So how can you call energized to trip a pump that you start to activate the functionality? Was very strange to me. That is why I said, let's start to call it different. And I'm not the only one doing it in the safety industry. There are many of my, let's say, colleagues in the industry doing the same type of topics. And they also call it energized to activate. Means that we are slowly starting to change the mentality in the people's mind, saying, actually, it's still energized to trip. However, let's call it energized to activate. Again, for the simplicity of this webinar, I call this here ETA, not to be confused with the event analysis. That's another ETA which you may have come across in some lectures, books, etc. So energized to activate, ETA, is never fail-safe. If you think about it, if your control platform has an internal failure and you cannot turn on the digital output module of that PLC, how can you call this fail-safe? That's why those type of modules are never called fail-safe. Those type of interlocks are never called fail-safe because we need that power to do something. That means that power, referring to the power supply role in your safety function, becomes a very, very, very availability issue now in the same story as it was a small availability issue also in the de-energized to trip. So power supply is indeed the availability issue. And common examples will be fire and gas, deluge, fire suppression, foam systems, high voltage protection, alarming, etc., etc. Since in normal operation, the loop has no power, that is where you may have, or you have seen that, or you know this already, that's where we're going to use the line monitoring. The word line monitoring means we're going to monitor the line in normal condition with no power to make sure the line is still there. Because if I go back to the de-energized and I cut the line, well, your system will lose the power and will have to go to a safe state. But if you lose the line here in a energized to activate, you may not know this without the line monitoring. And that is where you may see the end of line resistance, end of the line, to try to measure that you have still the line there, that you don't have an open circuit, that your loop resistance is still correct, that you don't have leaking, that you don't have earthing problems, etc., etc. But specific, all those items like the open, loop resistance, leaking, earthing, those are the items that we want to diagnose. And think about the following, folks, that if you are using an interposing relay which doesn't carry over those diagnostic functionality back into your control platform, you may lose all those functionalities. And that's going to be a very weak point if you don't think about that. That is the reason why we in GMI, we have specific line monitoring, which I already showed you, the smart relays. We can feed that kind of information back into the, let's say, safety platform or into the control platform, providing that if you put that isolating layer or that isolating relay between your control platform and your final elements, we can carry over those functionalities back into the control platforms. Now, if you think about that, I'm pretty sure that the Energized to trip examples, you have plenty of experience that you have seen, that you have a spurious trip in the field, that actually your functionality goes to a shutdown without any reason. We call this nuisance trip, spurious trip. Those are the ones that your process production people, your managers, your supervisors are hating because they lose production. Opposite, if you have Energized to activate, I'm pretty sure it's very rare, if any, that you have seen ever in your lifetime, you have seen a spurious trip that your Energized to activate was activated without any reason. That means there must be something in our configuration different, that we experience spurious trip in de-energize a lot, but Energized to activate, we don't experience the same. And that's something that we want to highlight here. So, if you have your digital output with line monitoring, as already mentioned, and you're using that interposing relay, that's sometimes being lost because your digital output stops all the way to the coil of your interposing relay. We want to carry this over all the way to the coil of your solenoid. And that is where the interposing relay with that smart functionality will be certainly a necessity, or let's say it will be necessary to have this functionality enabled to use that functionality benefit. And that's what I will show you over here. I got two examples by memory because I do not know the slides coming up. I don't have any preview, but I think we have two slides. One is this one. What is sometimes confusing, and I have seen it myself many times in configuration, sometimes people will use de-energized to activate, de-energized to trip examples or loops, enabled to energize to activate loops in the field. That means they kind of start to reverse engineering. That is why I start here with a direct engineering, and I call this direct engineering. That means to energize to activate. We are using here a relay where once the input, once we have a normally open contact here at the end, we're going to remove the energy over here, enable to remove the energy over here to activate. So when we are using this in an energized to activate example, meaning that once we energize the input, those contacts will be used to energize your final element. And that's an example here of energize the relay input to energize the loads. That's what the picture is showing here in a simple example. Input high, output high with some smart relay, with some monitoring diagnostics example. Now, assume that I want to reverse this. I want to use an inverse, let's say, activity. I'm going to use a different relay. And now we are using a relay here with a normally close contact. That means if I energize here, if I go here in my input and I actually de-energize that output from that de-energized to trip safety PLC, I can reverse the action with this relay and I can still energize the output to activate. So what I'm trying to say is here, often we will mix those. Let's say if your majority of your safety PLC signals, your outputs are all de-energized to trip, and you have a few energized to activate loop that you still want to mix in the same platform, you may keep your logic in the same zero logic, we call this, and you may reverse this output with this type of relays, which we show over here. So I want to come to a simple conclusion, just looking at my time, so we still have time for the Q&As. De-energized to trip is the only fail-safe principle. I hope that is clear now by those simple examples we have showed you. It will be a lot easier to design this, because even to maintain and even to understand, because the design is very straightforward. Energized to activate is often complex engineered or reversed engineered or creative engineered. And that's why sometimes those type of examples in the industry, may be a bit of a, let's say, a difficulty for the engineers to understand, especially by an engineer. Let's say 90% of all the examples, or 95, are all the energized to trip. And those are the simple examples for engineers to understand. Now, if you throw in a few energized to activate, sometimes it is confusing them. Now, frequently taught, that was the poll question, that the de-energized to trip does not need a reliable power supply. Well, I can say, of course, that's not 100% correct. That's also why we have still suitable power supplies with a systematic capability, as for instance also GMI is providing. And the last bullet here is the reference to report number 4, which is an informative section of the standard released in February 2020, clearly stating that it was often misunderstood that mitigation layers, in other words, energized to activate, did not belong to the standard, did not have to be built in a reliable section. Well, now we can say by the standard, it is also part that mitigation layers needs to be built reliable. Okay, before I will close my slides, very briefly, as Andrea, I was just have to think about the name, as Andrea was introducing, we as GMI also support with some services on the SIG 1511. Those are the support items. Those are the, let's say, the bullets that my department is trying to support in the industry. We are mainly currently busy today with function safety management and also with some assessments, safety requirement specification. We still do some determination and verification of safety loops. We sometimes help people with LOPA, and I say sometimes because it's not frequently asked anymore. And of course, we have a team also helping with PHRA, doing HAZOPs, doing all kinds of techniques to help specific clients to cover that. Besides this, we also help one of the topics in the industry, which is new by 2016 release, because now you are required to carry out a security risk assessment. That's the 62443 standard. And of course, I'm very happy to say that we finally, because we were on hold since March, but we started last week our first training course face-to-face. So we start to do face-to-face training courses around, for a moment, mainly in Europe. We will also run some, especially for the US, we will also start to run some remote virtual trainings where the exam is still being done on paper. So you still have to go to class to write the paper in different batches, different sections. But the training class will also be held virtually. We have the we have the cybersecurity and we have the security risk assessment training courses, which are currently still being carried out in a minimum configuration. And of course, we do the webinars for GMI. And as Andrea was quite rightly saying, that book is available. We do have it as an ebook. We do have it as a hard copy. If you write your email, we can send a book to you. And I will stop my sharing and Andrea will take it over now and he will start his question and answer section that we prepared.
Thank you, Tino. I see that still people are there, so nobody left. That's a good sign. And thank you for participating. Now we have a Q and question and answer part. So we try to answer to the most common questions, and Tino collected into one presentation. So if you don't have any real question now, you can of course write it and try to answer live. But in the meantime, we try to answer to the most common question. So you have to start with the presentation yourself.
Well, actually, the purpose was that you will start, but if you want, I can start and then you
Please, let's do it.
Okay, not a problem. I have it available here, but then I will have to share the screen, not an issue. Here we go. Share the screen, here we go. And then you simply take remote control and you can...
Okay, that's fine.
Okay, let's approve this again. If I can find my cursor, here you go. You have control.
Good. So the first question is, Tino, for you, what is the better approach for depressurizing valves, energized to trip or de-energized to trip? And also, which one is the best suitable for blow down valve?
Okay. All right. The reason why I have combined those two questions together, first of all, they both came from the same company, from two different engineers. So it's clear that those engineers are struggling, or at least may have a current topic in the company discussing that. So for those who are not so familiar with this, it's about depressurizing, so relieving the pressure from a vessel, unit, a column, etc. Otherwise, sometimes also called a blowdown valve. And based on my personal experience, this is personally experience from over 30 years, so I'm not saying I am experienced in that topic at all, but I've seen this question coming over and over again in a lot of forums, in a lot of webinars, seminars, even in training classes we have been doing. And I would classify this as a very, very common question. So it's not because those two people that were sending us this question before, you are special, you are unique. No, I think we have seen this all over. And I have to say, unfortunately, I don't have a one clear answer for you because there are many different scenarios which I could explain here, but I try to keep it very neutral. And I'm saying, like, let's talk about both design principles with an airfoil open or an airfoil close. You may say airfoil close valves to release the pressure is very rare. I would say probably yes. But again, both scenarios are out there in the field and can both have different problems to be discussed. So both designs with fail open or fail close have certain benefits and have certain disadvantages. Without going too much in detail, it all depends for which scenario you are investigating. And of course, which is your process application. Personally, as I said before, I don't think there is a one clear answer for both cases that will fit both. That is why you first have to think what type of application we are trying to relieve the pressure, what type of media is it, and very briefly or very shortly, without going too much in detail, assume that you are relieving a hydrocarbon, but because of the relief, your hazard becomes worse. You may discuss, well, what is now better to do in terms of a high pressure to relieve that hydrocarbon into the atmosphere that it can actually cause a worse scenario for a risk point of view, or can we actually try to relieve this pressure to maybe a more controlled area? So again, there's no one answer suiting all of that. That is why it needs to have some clear investigation to help you a little bit, which is not a functional safety standard. And I'm referring here to a API standard, which is the standard 521. For those who doesn't know the API 521 standard, that's a specific application note describing pressure relieving and depressuring systems. And I make a statement. And I actually copied the statement here in my slide. They said the valve should remain operable for the duration of the emergency or should fail in a full open position. And I'm really trying to emphasize here the or statement, because if you think about it, the valve should remain in the duration, should remain working in the duration of the emergency situation. That's actually applicable for both the airfoil close or the airfoil open. However, they all of a sudden throw also, not all of a sudden, they also throw an or in there. And because of the or, that's where the discussion will be starting. It should fail in a full open position. And that's something that you have to think about. So unfortunately, I cannot give you a clear black and white answer, but I try to give you a little bit items to think about. And again, API 521 may give you a little bit more guidance, more than I can do here in a functional safety webinar. All right, Andrea. Oops, I was controlling myself now.
No problem. So the next question was interesting to know if the use of accelerated power supply influence safety function in fire gas scenarios.
Okay, it's a specific fire case scenario, which is a very, let's say, special, unique question, because you can think about the fire case question. Was this person meaning a fire and gas application, or was he really meaning there is fire somewhere in the installation? So I thought, for the simplicity, let's talk about the fire and gas application. Let's talk about the energized to activate. Let's also talk about the de-energized to trip, as we showed that in in the webinar earlier, in the earlier slides. Now, the choice of the power supply is typically in the first place all about the availability. There's typically availability issues. Is my power supply available? Is it accurate? Doesn't provide me with, as we said already before, specific for the 61508 quality design of such a unit, which is shown here in this picture of a GMI power supply. It's measured on the measurements from the 61508 part 2, which is the hardware section. And we call this the effectiveness, or call it the rigorousness or the quality of the hardware design. And those techniques are used to measure how quality the power is being provided. It's all about the accuracy, the under voltage versus the over voltage, the latch up or high in rush currents, when you actually start up the power supply, or you reckon the hot swappable power supply, and the overcurrent. Now, if you come back on here, the choice of the power supply is depending on the specification needed. But things like redundancy, with load sharing, and hot swappable backups are very common practice. And I can say yes, the answer is yes, you're still rating your reliability issue on the choice of the power supply is a very, very correct item to investigate. Unfortunately, in the industry today, the current, let's say, commercial calculation SIL verification tools, not many are actually taking into account the reliability of the power supply to your final elements. It's often forgotten. But that's something that needs to be considered, and that's something that should be also considered in the future by those commercial packages available in the market. Okay, I'm gonna continue.
Right, Tino. So next question is, Energized to activate is a typical fire protection safety application. However, this is a mitigation scenario and not a prevention scenario. How do you achieve a low PFD average and reduce annoying spurious trip for a system which is almost never used? Very complicated question.
It's a long question. It's a long question, but let me just go back. Yeah, it is a long question, but it's a very valid question. I also know the person who sent us that question. That person, or let's say his company, is active in a certain domain in the industry. Now, Energized to activate, as I already mentioned in the webinar slides, even before coming to this question here in detail, I already mentioned it's very rare you will see ever a spurious trip. Systems designed Energized to activate tend to go not automatically to that activation, let's say, a method, unless, of course, it would be caused by the interposing relay. That is also why the interposing relay is such an important item to select very carefully. Look at the smart solutions in the industry, look at the diagnostic benefits, and that's something, again, which I would refer to the specific webinars of the relays that Andrea and his colleague Massimo are running. So, first bullet, spurious trips are rare, we mentioned that. They are often seen by de-energized, but not often by energized to activate. However, spurious trip would mean that the output would go to a energy position. It would be able to energize, and in case of a failure of that device, it would be very difficult. Assume that you have to energize a solenoid. You have to open a solenoid, but the solenoid is stuck. Well, that type of problem is the same, let's say, sensitive problem for de-energized versus energized. First come to the majority of the loops. De-energized to trip means the solenoid itself is in the wrong position for the majority of the time. The moment it has to close, it doesn't move. That's the same opposite if you would go to like a sprinkler system. You go to a sprinkler system, assume you would only use one solenoid. And the solenoid in normal conditions is closed because you don't want to sprinkle, you don't want to dilute your plant. That means in the majority of the time, the valve is always closed. The moment you want to open it, the valve doesn't work. That means in those type of configurations, people will go to a certain configuration, like as an example, a 2 out of 2, with two valves in parallel together, that either one of them can actually open, because we know spurious trip is very minimum, but we want to make sure that if we have to open the supply of water to the final valve to the sprinklers, that is actually working. So last bullet, fire and gas applications tend to be a lot less used. We all know that. Otherwise, you would live in a very strange plant or a very dangerous plant if you would use your fire and gas systems as frequent as your shutdown systems. That means that the mitigation layers tend to be used a lot less. It doesn't mean you have to build them a lot less reliable, because when you will need them, you will actually need to be trusting that you can use them. And that's why your, let's say, reliability or your SIL is also becoming a part of the 6.15.11 as per the edition number 2. Okay, Andrea.
Okay, Tino, thank you. So next question is: Energized to activate fire and gas systems for mitigation can be considered as SIS. I661-511 is applicable for fire and gas systems, and also the Energized to trip versus Energized to activate. Is Energized to activate feasible for SIF loop at all?
Well, we can be very short on that answer because we have been answering it in the webinar, and already on the previous questions it was also mixed in there. So again, design of reliable devices, such as, for instance, in the fire and gas applications, we need to look on the reliability of those devices also. And I give you a classical, let's say, common mistake. And I'm not pointing any finger to any vendor in the market at all. It's just a general neutral example. Assume that you have a gas detector, and the gas detector has gained the reliability, let's say, quality of a SIL2. It is SIL2 suitable. It is a systematic capability of SC2. There are even some SC3 on the market. Now, if you use that sensor in your area where the gas is actually in a certain, let's say, quantity available, well, the purpose of the sensor is, of course, to sniff and to recognize the gas. Now, if the gas is being blown by the wind to the wrong direction and there was no coverage by your gas coverage sensors, it will not make the sensor reliable because the sensor cannot even measure it. So the coverage of the mapping of your sensors is as well as important as the SIL2 on that specific device. But what is SIL2 on that device saying? That providing the sensor is being able to sniff it and recognizing the concentration of gas in that area, that signal needs to be correctly provided to the control platform, and that makes it a reliable sensor. Not the mapping. The mapping is another issue, which has nothing to do with the SIL. That's another topic. But here about the reliability of such specific examples. So, as already said over and over again, the misunderstanding was fire and gas mitigation doesn't belong in the 6.15.11. Well, it does belong in the 6.15.11. That is what report number 4 is now saying. All right, Andrea.
Thank you, Tino. If an application has a few energized to trip points while majority are de-energized to trip ones, what design consideration have to be borne in mind for power supply distribution?
Okay. Well, again, by not coincidence, but that was already in our slides before in the webinar. As I said, it's very common practice that engineers will start to mix those. Nothing wrong with that, but when they mix, and let's just stay on the safety PLC first. If you stay with the safety PLC de-energized to trip digital output modules, the functionality from de-energized to trip to energized to power is often being inverted by the interposer relay, which I already showed you in one of the slides of the webinars. And it makes sense to think about that. When the minority of your loops, the minority, is energized to activate, it would not really make sense to come up with a complete different platform of design to start to have two different design, let's say, systems, one to de-energize and one to energize. That's also why the majority of the safety PLC vendors, they also provide you with line monitoring digital output modules enabled to give you the solution from a platform interlock point of view. You are allowed to mix them. But often what we see in the industry, that engineers will not use that type of line monitoring module. They will actually use normal modules, and they will move that, let's say, intelligence into the interposing smart relay, such as the ones of GMI is providing in the market. So no matter how you solve your final solution to energize to activate, You need to think about what is the most cost-effective way to do it, as long as you are not losing your functionality of such a line monitoring, not by the module or not by the relay. That's also why I said smart relays can feed those informations back into the system. Now, if the question was meant to be more to the power distributor itself, I mean the power distribution in your marshalling cabinet, in your junction boxes, etc., that also needs some close attention, because now the availability for Energized to activate is different than for the de-Energized to trip. That is why it needs again some, let's say, engineering attention in the way your I/O assignment, in the way your wiring, in the way your power distribution in your marshalling cabinet, all the way from a power supply over your fuses in your marshalling, etc., etc. That needs to have some, let's say, very close attention. And as I said, GMI is one of the few vendors in the market providing you with SIL-rated or SIL-suitable power converters, I like to call them, because you need to provide power in and they will actually control the power out. That is why I call this a power converter, although the majority of the people call this a power supply. That's just a personal interpretation of the word supply versus converter. All right, Andrea. Oops, I'm finished.
Almost finished. Thank you, Tino. Yes, it's almost the end. So we like to remind you that we have all our webinars. This Tino has different topics for functional safety, and we schedule other webinars on our website. So you can check our website. You can also look at this and maybe forward to your colleagues this webinar that is has been recorded, as well as the other. So we have a YouTube channel, and the link on our YouTube channel is on this on our website. So you can look at all the other webinars we had in the past month. Thank you. So we like also finish with the last poll. So if you want just rate it, oh, sorry.
That's okay. You want to see the
something
slide?
That you can do, but I can start with the poll.
Yeah, let me just share the slide again.
Yeah.
But you have to start the poll, right? Okay.
Yeah. Please rate this webinar. Thank you very much. Also, your vote will be anonymous without your name, so don't worry if you want to. Thank you. Well, okay, we can stop it now. Almost all participants voted. Perfect. Thank you very much. Thank you, Tino.
Thank you, Andrea. We also have to go to the closing. I just go to the closing. Those are our contact details.
Yeah. If you want to make any question, just don't wait. Send us an email. You will get a proper answer. Thank you, and
thank you, Andrea. Have a
thank you all participants.
Keep it safe, keep it healthy for everyone, and see you on one of the next webinars from GMI. Thank you again.